So, okay, everybody. In last class, I talked about the lymphatic system, right? And you already know that lymphatic system is responsible for immunity, protecting your body, right? So, what is immunity? Immunity is the ability to fight antigens, to fight against antigens. Now, antigens can come from outside of the body. For example, what? Bacteria, virus, right? Try to invade into your body and cause harm to your body, right? But you already know that antigens can be produced inside your own body. For example, tumor cells, cancer cells, right? Those abnormal cells are also antigens. So antigens try to harm us, right? And cause diseases. And our body has that ability to fight against them. And that is the immunity, defensive functions or mechanisms of your body. Now, in your body, two types of immunity are present. One is called innate immunity that we all get by birth. And another type of immunity is adaptive immunity. Adaptive immunity is different in different persons. Innate immunity is what? Everybody we have and we get by birth. Adaptive immunity develops in your body when you get exposure to any antigen. That's why it is different in different person. Make sense? Because in your lifetime you got exposed to some types of antigens. Another person got exposed to different types of antigens, right? So adaptive immunity develops in your body in response to what? Antigen, and that is different in different person. So we'll talk about those two types of immunity. Then we'll talk about antibodies, types and structure and properties. Then we'll talk about cell-mediated and humoral immunity, active and passive humoral immunity. So first, the immunity, as I have already mentioned, could be two types, innate and what? Adaptive. Adaptive immunity has another name. It is also called acquired immunity. Now, innate we get by birth. That's why everybody has the innate immunity already when we're born. For example, skin. Make sense? Everybody has skin, right? That covers the body and protects your body. So, skin. Another lining is the lining of your respiratory tract and the lining of your GI tract. Inner lining of the respiratory and gastrointestinal tracts. Those linings are called mucosal lining of what? GI tract and respiratory tract. So, when an antigen, for example a bacteria, tries to enter into your body, who tries to stop it first? Skin. We all know that skin covers the whole body, right? Now, if that bacteria tries to enter into your body through the respiratory tract, then inner lining of the respiratory tract will try to stop it, right? That is the mucosal lining. Make sense? If it tries to enter into your body through food, then inner lining of the GI tract, right, will try to stop it. So, all these belong to first line of defense. Okay? They try to stop the antigen first, your skin and the mucosal linings of your GI tract and respiratory tract. That's why they belong to first line of defense. Now look at me. If your skin fails to stop it, then it will enter into the tissue, right, under the skin. Your tissue has few things, and those things will try to destroy the antigen or bacteria. So, if first line fails to stop, then the antigen enters into the tissue under the skin, and in your tissue you have antimicrobial proteins, tissue proteins, antimicrobial proteins. Those are tissue proteins, proteins in the tissue. Make sense? Interferons. Interferons also destroy the microorganisms or antigens. And another important components are called complements. Okay? So these important chemicals or proteins are present in the tissue, and they try to stop and destroy the microorganisms or antigens. And therefore, these belong to second line of defense. And the innate immunity, now you tell me, if I ask you, your skin, is it specific or non-specific? Is it trying to stop any particular antigen or any antigen? Non-specific, right? It will try to stop everything. Mucosal lining, same, right? Also, second line defense, these antimicrobial proteins, interferons, complements, as well as another important one is phagocytic cells, macrophages. Macrophages. All these are non-specific Macrophages try to engulf any abnormal cell. Tissue proteins will try to destroy any abnormal cell or microorganisms. So, innate immunity is non-specific. It will try to destroy any kind of antigen, not particular one. Adaptive immunity is highly specific. And develops in your body in response to an antigen. Make sense? In response to an antigen. Now you tell me, if you get swine flu virus, have you heard swine flu? Okay. So if you get swine flu virus, adaptive immunity will develop in your body against it. Make sense? But that adaptive immunity will develop only in your body, not another person's body, because only you got that virus. Is it clear? If another person gets like, herpes virus, okay, your body will develop antibody against it. Okay, so adaptive immunity is highly specific against that particular antigen. Is it clear? And that's why it is different in different person and highly specific, and develops once you get exposed to an antigen. Now, adaptive immunity is called third line of defense. Okay, third line of defense. So there are how many lines of defense? 3. First and second lines are given by innate, right? And those are non-specific. Third line of defense is adaptive or acquired, which is highly specific. Now, adaptive could be 2 types: cellular and humoral. Cellular immunity and humoral immunity. Okay, let me see if it. Okay. Cellular is given by T lymphocytes. We talked about that before. T lymphocytes. Cellular. Humoral is given by what? Make sense? We have T and B lymphocytes, you already know, right? T lymphocytes get matured where? In the thymus. And B lymphocytes in the bone marrow, yeah? Right? You remember in last class I mentioned, they get their training, right? And come out as T and B. And they learn to fight same way or different ways. They are trained in 2 different places, right? So they learn to fight in different ways. T cells directly come contact to the antigens, usually. And B cells do what? Release the antibodies. Remember, I said that you can grab or you can shoot or throw something, right? So, 2 different ways. Is it clear? Okay. So, humoral immunity is given by which type of lymphocytes? B lymphocytes, right? And we know that B lymphocytes produce what? Antibodies. That's why it is called humoral. Do you know the meaning of humoral, the word? Humoral? Humoral means fluid. Antibody is secreted, right? So it's like fluid. Have you heard aqueous humor, vitreous humor? No? Yes? Where? In the
Right.
eyeball. Do you remember aqueous humor?
Yeah.
Vitreous humor. Okay. So inside the eyeball, right? You have seen it when you dissected the eye. Okay. So humor means fluid. So humoral immunity is given by antibodies, fluid, secreted by B cells. Now, humoral could be two types. Active and passive. So here, let's see, active humoral and passive humoral. Active and passive humoral. Okay? Now, what is the difference between active and passive humoral? If I inject antigen, bacteria into your body, okay, your body will produce what? Antibody against it, right? That's the normal response of your body. It will produce antibody against an antigen. Okay? So, your body is actively producing antibody, right? So, that is an example of active. If any antigen enters into your body produces antibody against it. Is it clear? Active. Now you tell me another example. Infant gets mother's milk, right? And in mother's milk, you have antibodies. So, when infant gets mother's milk, infant is getting antibody from mother's milk, right? Is infant's body producing it or getting from mother? Getting from mother, right? So that is active or passive? No. Infant's body is not producing it. Getting from another person. So that is passive. Make sense? Active is your body is producing. And passive is your body is getting from outside antibody, not antigen. Okay, I'm explaining again if you didn't understand. This is very simple. If any microorganism, which is antigen, right? Antigen enters into your body actively produces antibodies against it. So that is active immunity, right? Your body is producing against that microorganism. Now, in passive, your body is not producing antibody, getting from another person's body. Infant is getting antibody from mother's milk. Make sense? So he is ready-madely getting antibody, not producing any antibody. So that is passive. Okay? When you get vaccine shot, like flu shot, okay? You know what is vaccine? Vaccine is antigen. You are getting antigen from outside. But why, it's not harming your body? Because we give the antigen in such a small amount, okay? And we highly inactivate those antigens. Like, if I break someone's leg and hands, that person is alive but cannot do what? Fight. Make sense? So, when we make vaccine, we highly attenuate or inactivate the antigens in a way that can enter into your body and can produce antibody in your body but cannot cause harm. So harmless way we inject antigens. Make sense? It is effective enough to trigger the production of antibodies in your body, but not effective to cause disease or harm. Make sense? So that is vaccine. So vaccine is active or passive? active because it is antigen. So now the bottom line is active. In case of active, you can write it down. In case of active, antigen enters into your body. Simple. Who enters? Antigen. In case of passive, your body gets what? Antibody from outside, not antigen. That's the difference. Is it clear? So vaccine is what? I said antigen, right? Highly attenuated antigen. So that is producing antibody in your body, so that is active. Make sense? Now, I will give you two examples of active. One is from nature, your body got flu virus. Flu virus from nature. Your body produces antibody against it, right? So that is one. Another is I'm injecting antigen as shot vaccine into your body is producing antibody against it. Both are active, right? Because I'm injecting or you are getting antigen from outside. Now which one is natural, which one is artificial? Vaccine is what? Artificial, right? And from nature, your body got the flu virus, that is natural. So is it clear? So active could be two types. Natural like microorganism enters into your body, and artificial is vaccine produced in the factory, sold in the pharmacy, right? It's not natural. So, active, artificial, active, natural. Now let's talk about passive. In case of passive, your body gets antibodies from outside, not antigens. For example, mother's milk, right? Antibodies enters into infant's body. So that is natural or artificial passive? Natural. Make sense? So passive could be also natural and artificial. Okay? So infant gets mother antibodies from mother's milk, that is natural passive. Now let me give you an example of artificial passive. Have you heard AIDS virus, right? HIV, that destroys the immune system, right? Destroys the immune system. Like someone got AIDS, his immune system has been destroyed, right? Any antigen can easily cause harm to that person, right? Because his body doesn't have immunity, right? In that case, what we do? We inject antibodies from outside, because that person's body cannot produce antibody anymore, right? So you have to inject what? Antibodies from outside. So two examples I gave you. One is infant is getting antibody from where? Mother's milk. Antibodies from mother's milk, right? And AIDS patient gets antibodies from the pharmacy or as medicine. So both are passive, right? Getting antibodies. But which one is natural? Infant getting mother's milk, right? And which one is artificial? The AIDS patient is getting antibodies from outside. Is it clear? So it could be also artificial. Passive could be artificial and natural. Is it clear? So this is the classification of immunity. Let's quickly review. First, the immunity has how many divisions? Two. Innate and adaptive or acquired, right? Innate gives how many lines of defenses? Two. first line of defense and second line of defense. Is it clear? Skin, mucous membrane of your respiratory and GI tract, those belong to first line of defense, right? If first line of defense fails, antigen will enter into the tissue, right? Under the skin, where you have what? Antimicrobial proteins, you have interferons, you have complements, okay? Those proteins will try to destroy the antigen. So they give which line of defense? Second line of defense. Is it clear? Okay. So adaptive gives the third line of defense, and highly specific, only adaptive immunity will be developed or grow in your body in response to specific antigen, right? Is it clear? Then adaptive could be cellular and humoral. Cellular is T cell mediated, T lymphocyte mediated, and humoral is B lymphocyte mediated. B lymphocytes produce what? Antibodies. Is it clear? That's why it is also called humoral. And it is two types of humoral, right? Active and passive. And both could be natural and what? Artificial. Is it clear? Okay. So that is the classification. Now, T cells or T lymphocytes could be how many types? 4 types. Cytotoxic T cells, helper T cell, suppressor T cells, which are also called regulatory T cells, and another is memory T cells. Cytotoxic T cells are also called, you can close the door if you want. Cytotoxic T cells are also called what? Natural killer cells. Natural killer cells. They love to kill the abnormal cells or microorganisms, bacteria. How cytotoxic T cells work? This is a bacteria, okay? And this is cytotoxic T cell or natural killer cell. When the bacteria comes close to cytotoxic T cell, cytotoxic T cells release some granules, some chemicals. It's kind of granules called perforins. Okay, so cytotoxic T cells release perforins, and these perforins get attached to the cell membrane of the bacteria. Get attached to what? The cell membrane of the bacteria. Perforins. Make sense? And make holes or pores in the cell membrane. So perforins make pores or holes in the wall of the bacteria. And then after that, what happens? The cytotoxic T cells release another chemicals. These chemicals are called enzymes. And these chemicals will enter into the bacteria through those pores or holes. Will enter into the bacteria. Is it clear? Enzymes. And will stop the metabolic activity of the bacteria. Is it clear? So if the metabolism stops, then the bacteria will stay alive or die. If I stop the metabolism in your body, you will die, right? So, no metabolism, no life, no ATP. You know, ATP comes from metabolism, right? So, cytotoxic T cells, when come close to a bacteria, it releases what? Porphyrins, right? And porphyrins get attached to the cell membrane of the bacteria and make what? Holes. And then cytotoxic T cells release what? Enzymes. That will enter into the cell and stop the chemical reactions, metabolic activities. So the bacteria will die. Is it clear? So that's how cytotoxic T cells can kill the bacteria as well as cancer cells or tumor cells, abnormal cells. Okay, so this is done. Helper T cells. Helper T cells work differently. So this is a helper T cell. Helper T cell, and this is a bacterium. Or bacteria. And there is another cell works in between, that is called antigen presenting cell. Okay, so three cells are here: antigen, bacteria, antigen presenting cell, and helper T cell. This one. So when the bacteria comes close to the antigen presenting cells, the bacteria gets attached to the antigen presenting cell, and antigen presenting cell then stimulates the helper T cell. So bacteria is not directly stimulating the helper T cell. Bacteria gets attached to the antigen presenting cell. So this cell will present this one to this helper T cell. That's why it is called antigen presenting cell. And the antigen presenting cell will present this antigen to this helper T cell, and now the helper T cell will do what? Will release very important chemical that is called cytokines. Probably some of you have heard the name cytokines. There are different types, very powerful. Now, cytokines do what? Stimulate both T cells as well as B cells. So both cellular and humoral immune systems are activated or stimulated by cytokines. Is it clear? You know, T cell mediated, B cell mediated immunity, both are activated. So that's how the helper T cell works. Make sense? So cytokines activate T cell mediated, B cell mediated immune system. That means both. Suppressor T cells, also called regulatory T cells. Suppressor T cells are very interesting. All these are interesting, right? So suppressor T cells, suppressor I'll ask you after this, okay? Everybody be alert. I will test if you are listening. So suppressor T cells, its name is telling you, right? It suppresses the immune system. Now, if I suppress your immune system in your body, is that good or bad? Bad, right? Because your body needs immunity, right? But sometimes, if your immune system is hyperactive, overactive, that can cause hypersensitivity responses or reactions in the body, right? So, hyperactive immune system is not good. Have you heard autoimmune diseases? So, if your immune system becomes hyperactive, sometimes it can start to kill your healthy cells too. Instead of killing the abnormal cells, it can start to kill the normal cells too, right? Or at least will cause some immune response in your body, allergic reactions. One kind of immune response, you know, inflammation. So, sometimes your body needs to suppress the immune function, right? If it tries to overact. So, the suppressor T cells do that, okay? So, it tells that it's time to slow down, okay? Time to slow down. So, that is suppressor. Now, memory T cells. So, suppressor T cells are helpful to prevent autoimmune diseases. Make sense? Autoimmune diseases. Memory T cells. Memory T cells are also called antigen experienced T cells. Also called what? Yeah, antigen experienced cells. That means these cells, the memory cells, got exposed to an antigen before. Make sense? Like you got swine flu, again, same example, okay, before. And now you got, you know, recovered from that, you are good. After 10 years, if same type of swine flu virus again tries to enter into your body, these T cells once got experienced, right, or got exposed to those antigens, they will quickly respond to fight against that particular type of antigen. That's why you all know that we say that if you got any, you know, microorganism in your body before, the chance of getting attacked again is less or more second time? Less, right? We say less because your body has the memory of that, you know, prior invasion. Is it clear? So, how? By creating the memory cells. Yes.
So is that what really kicks in when you have the attenuated virus of a vaccine? Is that the cell that primarily kicks in because your body's already been exposed to it?
Yes. So vaccine is basically creating some antigen experienced cells, okay, the memory cells, right? So that will make your body ready to, you know, quickly fight. And if you fight quickly, then the microorganism will not spread, right? But if you give more time, it will spread more, right? So quick response is very important to destroy the microorganisms, yes. And the vaccine gradually gets weaker, the effect. So after like every 5 years or 10 years or couple of years you need to get it. So different vaccines have different duration of action. Okay, so those are 4 different types of T cells and how they work. B cells could be plasma cells, and memory B cells. So B cells also could be antigen experienced B cells, and plasma cells, remember, are especially important because plasma cells can produce plenty of antibodies. Okay, so some B cells are converted to plasma type B cells and they produce plenty of antibodies. Okay. So this is the part of classification where I started from humoral, B cell mediated. Antibodies. Antibodies are proteins. How many of you remember plasma proteins? How many types of plasma proteins in the blood? 3. What are those? Everybody. Albumins. Albumins. Plasma proteins. Albumins. You forgot the plasma proteins? That's the very basic thing. Albumin, globulin, fibrinogen. Remember that? Albumin, have you heard the name before? Albumin, globulin, fibrinogens. Globulin is responsible for what? It does some transport. All of them do transport. Globulin.
A histamine kind of thing? Is a globulin more akin to a histamine?
Simple way, say. Albumin responsible for colloidal osmotic pressure. Globulin, I gave you just one function. Globulin responsible for immunity. Is it? Forgot? Okay. So globulins responsible for immunity, right? So one type of plasma protein. Make sense? So antibodies are globulins, and these globulins are called immunoglobulins because they give what? Immunity. Those globulins give immunity. Those are called immunoglobulins. And produced by the plasma cells. Now, the structure of an immunoglobulin could be Y or T-shaped. So, antibodies or immunoglobulins are usually Y or T-shaped proteins. And if you see an antibody, this is antibody. It has 2 portions, fixed part or constant part, fixed or constant, and flexible or variable part. So this part is the fixed part and this part is the variable part. Okay? This is variable part, this is fixed part. So look at this. This is an antibody. Okay? So it has how many parts? How many parts? Two. One part is the fixed part, another part is the variable part. Okay? So this part is fixed, right? So it will stay there. And this part is variable part. So this part can be changed, right? Like I changed this part. And this part gets attached to the antigen to destroy the antibody. Make sense? Now, if your body gets one type of antigen, this variable part is perfect to bind with that antigen, okay, and destroy it. Is it clear?